So you guys have done inverse in O levels, okay? Although the kind of inverse that we do in O levels is probably like 10% of what we will do in AS Math. But whatever you remember, I'd like to know. What do you remember of inverse functions from O levels? O levels or IGCSE? You remember the step-by-step procedure? How many steps were there? I think there were like 3, 4 steps, depending on how you break it down. Yeah, make X the subject. Long story short, what you do is you make X the subject. Okay. Substitute F, make, then swap Y and X. Substitute F of X with Y, then make X the subject. Okay. So what you guys remember is correct. We'll just go over it one more time formally. Okay. And yeah, that will help as a quick refresher. So we'll do this through an example. Okay, we'll do this through an example. So here's an example of a linear function of which we're going to find the inverse. So let's say that you're given f of x to be equal to 3x plus 5, and you're asked to find f inverse of x. Okay, so what are you asked to do? You're asked to find f inverse of x. So it's a 3-step process. Okay, 3-step process. Acha, before I do the 3 steps, let's just quickly do one thing which will help us further understand how the domain and range works when we're dealing with an inverse. So here are some random values of x which I'm going to plug in, and then I'm going to see the respective output of those values. Okay, so let's say we plug in 1, let's say we plug in 2, and let's say we plug in 3. Okay, and we're going to plug it in this function. So if you plug in 1, it's a no-brainer. 3 into 1 is 3. 3 plus 5 is going to be 8. So that means when 1 is the input, the output that we get is 8. If you plug in 2, 3 into 2 is 6. 6 plus 5 is 11. So if you plug in 2, you get 11. So 11 is the output. If you plug in 3, what do you get? 3 into 3, that's 9. 9 plus 5, that's 14. Okay. So keep this in mind. Why? Because we will use this later on to understand a very important concept. Okay. So let's find the inverse. What's step 1? Step 1 is that you replace f of x with y. Now this step is not entirely necessary. We just do it because it helps with the whole algebraic manipulation. Okay, that's the only reason why we do it. So if we do the first step, what are we looking at? We're looking at, in fact, let me do it with a different color. We're looking at y is equals to 3x plus 5. So this is step 1. What's step 2? Step 2 is that you make x the subject. So here's step 2. Step 2 is that you make x the subject. Or rewrite the whole function, making x the subject in terms of y. So if you do that, again, this also will be done step by step. Y minus 5 equals to 3x. Y minus 5 upon 3 equals to x. Let's write this nicely. So x is equals to y minus 5 upon 3. Okay, so you've done the core steps now. Okay, you've done the main steps, except that there's one more step which you have to do. And this is also very important. And that is that you replace x with f inverse of x, all right, and y with x. Okay, so I'll do this step. Replace x with f inverse of x, since that's what you were supposed to find to begin with. Okay, and what are you supposed to replace y with? You're supposed to replace y with x. And there you go. What you've done is you found the inverse of this function right here, which was 3x plus 5. And what's the inverse? The inverse is x minus 5 upon 3. Okay. Now, any questions? If yes, feel free to ask. Okay, so I'm judging by the silence, no questions. Now, here's something interesting, and I want you guys to make an observation over here. What I'm going to do now is I'm going to plug in some values in the inverse function, okay? And these values are going to be the range or the output that we got in the regular function. So from now on, I'll refer to f of x as the regular function and this as the inverse function, okay? And I want you guys to make an observation. So I'm going to plug in 8, 11, and 14 one by one, okay? So I'm going to plug in 8, 11, and 14 in the inverse function, and we're going to make an observation regarding the output that we get. Okay, and with that, we'll come up with some standard rules. So if you plug in 8, 8 minus 5 is 3. Yes, very good, Nayan. 8 minus 5 is 3. 3 upon 3 is 1. All right. If I plug in 11, 11 minus 5 is 6. 6 upon 3 is 2. And if you plug in 14, again, if you've identified the pattern, you would know exactly what's going on. 14 minus 5 is 9. 9 upon 3 is 3. Okay. So make an observation. I'll zoom out so you can see all the relevant information to make that observation. Go ahead. What just happened? If x is increased by 3, the output is increased by 1. Okay. All right, but that's not what what I'm looking for. Range of the inverse function gives you the domain of the regular function. Yes. Okay. So notice what's happened is that the roles have changed. Okay. Well, what do I mean by that? The domain of f of x, domain of the regular function, has now become what? Has now become the range of the inverse function. Okay. And not only that, doesn't end there. Range of f of x, the regular function, has now become the domain of the inverse function. Okay, let's write this down. This is very important. And we'll learn why this happens. Okay, we'll learn graphically why this happens. So, note. And I'll write this in red so you guys know that this is important. The domain of f of x becomes the range of f inverse of x, okay? And the range of f of x becomes the domain of f inverse of x. Now, any idea why this has happened? Any idea why this? Why all of a sudden the domain, why all of a sudden the range has become the domain of the inverse function and the domain has become the range? Think about it, put some thought into it. There's no rocket science. Anyone? Doesn't matter if you get it wrong, but still give it a shot. No idea? Okay, I'll tell you. So the reason why this has happened is because we are inversing the equation. Okay, yes, we're doing that, but that's not exactly a clear explanation as to why this has happened. So I'll tell you why this has happened. So what we have done is, previously, what was our input? Our input was x, okay? In the process of finding the inverse, what do we turn x into? We turn x into the output. Why? Because we make it the subject. And what is the subject is the output. Here, f of x was the subject, so f of x was the output. In the inverse function, before we replaced it with f inverse of x, we made x the subject. So what's happened is that your domain has now taken place of the range in the inverse function. That's why the domain of f of x has now turned into the range of f inverse of x. Because what you do is you basically switch places, you swap places. You swap places of the domain with range and of course vice versa. Okay, so that's the reason why this happens. Now, okay, I'll explain this one more time. So the reason why this has happened, the reason why all of a sudden the domain of f of x has turned into the range of f inverse of x, and of course the other way around, is because when finding out the inverse, what do? We make x the subject. So x previously is your input, is what you plug in. But when you make it the subject, it becomes what? It becomes your output, which means it becomes your range. Okay, and becomes the range of what? It becomes the range of the inverse function. So notice what's happened. X has become the range of the inverse function. And x of what? X is the domain of f of x. That's why domain of f of x becomes the range of f inverse of x, and range of f of x has become the domain of f inverse of x. And we can see that here. When you plug in 1, 2, 3, you get 8, 11, 14 in the normal function, in the regular function. I'll write down f of x here. Okay, so this is f of x, this is your domain, okay, and this is your range. And this is f inverse of x. Yeah, so long story short, they switch their positions basically. F inverse of x, this is your domain, and this is your range. Okay. So in simple words, output becomes range, input becomes domain. No. In simple word, your input becomes the range and your output becomes the domain. The other way around. Because x is your input, which then becomes your range, and your output becomes the domain because you change places with f, because they change places. All right? In simple words, remember this. Okay? This is as simplified as it gets. Okay. Now, another very important root, and that is inverse. So what do you think? We can find out inverse of any function there is? Or just you think there is a specific condition? I remember you guys telling me about this when we were discussing the kind of functions. Although it was not something we covered then, but we're going to cover it now. When can the inverse of a function exist? Yes, only when it's a one-to-one function. So remember, inverse of a function will only exist if it's a one-to-one function. Okay. Acha, why not many-to-one? That's a good question. So I'll tell you why. Why not many-to-one? In a minute. Okay, I'll tell you why not many-to-one in a minute. Okay, because we'll get to it in a minute. Okay, remind me to answer your question. It's a good question. Not a lot of people are interested in finding out why that's the case, but I will answer it. First, let me finish what I've just started. So normally you will come across a lot of questions where you're dealing with a quadratic function, okay? And the examiner will ask you to write down a specific range so that the inverse exists, okay? So let's say that you're looking at a quadratic function, a quadratic curve, such that it's turning at the x-coordinate of the turning point is 2. Okay, everything else is irrelevant, but what's important is that the x-coordinate of the turning point is 2. Okay? So as of now, will the inverse exist? Yes or no? As of now, will the inverse exist? Yes or no? No, it doesn't. Okay, and what's the domain as of now? The domain is that x belongs to the set of all real values. Okay, so at this point, what do we say? We say the inverse does not exist. Okay, and questions like these are very common. But something can be done to the domain so that the inverse exists. Okay, we can change the domain slightly. We can alter the domain slightly so that the inverse will exist. And we have two options. Either we keep the half that's after the x-coordinate of the turning point or before. So what if I keep the half that is after the x-coordinate of the turning point? What am I looking at then? Then I'm looking at something like this. Now it's become what? Now it's become an increasing function. And if it's an increasing function, that means it's a one-to-one function. And if it's a one-to-one function, what happens as a result? The inverse exists. Okay. Just like that, there's something else that can be done to this very function so that the inverse will exist. And what is that? That is, we change the domain and we keep the half before the x-coordinate of the turning point, where x is lesser than or equal to 2. And as a result, what will happen? The inverse will exist. Okay? So questions like these are very common, that what can you do to the range so that the inverse exists? Okay? Okay, so take a good look at what I've done so far. Let me know if you have any questions, and then I will answer Taha's question that why is it not possible to have the inverse of a many-to-one function? So if you have any questions, like I said, feel free to ask. Sir, can you explain the inverse does not? Okay, so remember, inverse of a function will only exist if it's a one-to-one function. Okay, so that means if you have a many-to-one function, which is a function, but you can't find out its inverse. Okay, But you can alter the domain slightly so that the inverse can be found out, so that the inverse exists. And what are the conditions? The condition is that either you keep the part of the curve that's after the x coordinate of the turning point, or you keep the part of the curve that is before the x coordinate of the turning point. Then what happens as a result? This becomes a one-to-one function. Okay, and do you guys remember the test for a one-to-one and a many-to-one function? What's the test? How do you distinguish between a one-to-one and a many-to-one function? Question for you guys. What do we do? Horizontal line. Good job. And what's the condition? What happens if it is a one-to-one function? What should the horizontal line do? Line cuts once. Okay, good job. Okay, so now let's answer Taha's question that why is it not possible to have an inverse of a many-to-one function? Anyone who has an idea why it's not possible, please share it. Why inverse does not exist if Sir, the reason, okay, somebody's shared something. Sir, the reason why we can't get inverse of a many-to-one function because we can't take root of a negative coordinate. No, that's not the reason. That is not the reason. Okay, so can anyone give me an example of a many-to-one function? We just dealt with one earlier. Quadratic, brilliant. Okay. So what happens in a quadratic function is that you have many values giving you the same output. ऐसे है ना? In a quadratic function, you have many values. Yes, good job, Taha. So if let's say you have 1, 2, 3, let's say you have 4, 5, and 6. So in a quadratic, it's possible that 1 gives you 4, 2 gives you 5, and 3 also gives you 4. Okay, so this is an example of a many-to-one function. Okay, f of x is a many-to-one function. Now, what happens if I inverse it? We just saw earlier that the domain will become the range of the inverse function, and the range of f of x will become the domain. And you can probably see where we're headed. You can probably see what's going to happen. So here we have f inverse of x, and here we have x. So if I plug in 4, 5, and 6, the problem is that 4, which was previously the range, has now become the domain. And 1 and 3 were previously what you would input to get 4. Now what will happen if you plug in 4 in the inverse function? You will get 2 different outputs. And what happens when you get 2 different outputs? You will get 1 and 3. And then if you plug in 5, if you plug in, let's say, if you plug in 5, you will get 2. What happens if you get 2 different outputs? What's wrong in a situation like this? What happens if you plug in one value and you get 2 different outputs? What do we call it? Yes, it has become a relation. Okay, it becomes one-to-many, and one-to-many is not a function. Okay, this becomes a one-to-many relation, therefore not a function. Okay, so I hope that that's clear now. Taha, all good now? Okay, great. So another very important thing for you guys to know is the graphical relationship between f of x and its inverse. Okay, so the graphical relationship between f of x and its inverse. And let's just call it f of x, f inverse of x. Okay. So let's say you have f of x equals to 3x plus 5, something that we dealt with earlier. So quickly, let's draw it. Okay, we're not sketching, we're actually drawing it. So we can clearly identify the difference. So, okay. Now, previously, let's see what happened. When we plugged in 1, we got 8. Okay, so here's what I'm going to do. This function, the normal function, I'm going to draw using the color green. Okay, so previously when we plugged in 1, we got 8. So that's right here. And when we plugged in 2, what did we end up with? When we plugged in 2, we got, let's see, we got 11. And when we plugged in 3, we got 14. So at 2, we ended up with 11. At 3, we ended up with 14. Okay, now, so let's draw it, let's sketch it, let's extend it a little. So yeah, here you go. Now let's talk about the inverse, which I'm going to make using the color red. So the inverse function was basically x minus 5 upon 3. Okay, and what happened in the inverse function? In the inverse function, if you plugged in 8, you got 1. Okay, if you plugged in 11, you got 2. And if you plugged in 14, you got 3. Okay, so does this remind you guys of something? Observe the points and tell me if it reminds you of something. So in the normal function, this is what we had. We had 1 comma 8, we had 2 comma 11, and we had 3 comma 14. Okay, in the inverse function, this is what we end up with. We ended up with 8 comma 1, we ended up with 11 comma 2, and we ended up with 14 comma 3. So yes, switch. Okay, elaborate, narrow it down. They're mirroring each other and the line of symmetry goes through origin. Okay, that's true. Yes, transformation and it's a reflection along the line y equals to x. So it's very important for you guys to remember what f inverse of x looks like graphically in relation to f of x. Okay, so it's very important for you guys to remember the graphical relationship between a function and its inverse. Not like you will have to draw this accurately, but yes, you will have to sketch it. Okay, maybe the question will give you a normal function and then it will ask you to use the normal function and sketch its inverse. And all you got to do is you got to swap the points. Okay, so swap the coordinates. What is the graphical relationship? Let's write it down. It is a reflection. Oops, sorry. It's a reflection along the line y equals to x. Sir, will they give x value so that we can put it in the equation? No. I'll tell you what a question can look like. Okay, I've taken out some questions. We will solve them, but let me give you an idea already of what a question will look like. Okay, so this could be an example. So you have the graph of y is equals to f of x, and the question is asking you to draw the diagram of y is equals to f inverse of x. So it's a 1-mark question, and the question is how exactly are we going to do it? So what we need to do is we need to reflect this. Okay, we need to reflect this along this line, and we need to reflect this along this line. So this is your mirror line. What you need to do is you need to reflect this along the blue line and you need to reflect this along the blue line as well. So what will the end result look like? So the end result will look like this. You will have this. This is basically a reflection of this part of the curve. And then you will have this, which is a reflection of this part of the curve. Okay? Not that complicated. Very simple. Let's look at another question where you may be dealing with the same concept. Yeah, like for example over here. Copy the diagram on your copy sketch and sketch on your copy, sketch the diagram, sketch the graph of y is equals to f inverse of x. Now you don't have questions like these anymore. From now on, from 2018 onwards, I think, you don't have to copy the diagram anywhere. You have to solve it on the diagram itself. So here, what you have to do is you have to make an inverse of this function. So you'll have to find out some value. So for example, you have to find out what this value is, and you'll have to find out some other values in order to make a sketch of the inverse. But what's important is that you will basically reflect this curve along the line y equals to x, okay, with obviously some values. So when we get to some questions, you will have a better understanding, okay. Right now, this example is good enough, but when we start solving some questions, you'll have a better understanding, okay. Okay, so moving on, let's do some practice questions, okay. Let's solve some questions. I'll solve some questions and then I'll give you guys some questions to solve. So we've seen how to find out the inverse of a linear function. Okay. Let's do another example. This is going to be example number 2. Let's say you're given f of x is equals to x squared minus 6x plus 5, and you're asked to find f inverse of x. So what are you going to do? How do we find out the inverse of a quadratic function? We know that we have to make y the subject. Okay, let's do it step by step. We have to replace f of x with y and then make x the subject. So here's the first step. Now the question is, how do I make x the subject over here? Yes, completing square. Okay, so remember, one very important rule is that in order to find out, we'll write this down also, in order to find out the inverse of a quadratic function, you have to first bring it in completed square form. Okay, I'll repeat. In order to find out the inverse of a quadratic function, you have to bring it in completed square form. Note another standard rule. In order to find out the inverse of a quadratic function, we need to first bring it in completed square form. Okay? So if you try and do it without it, you're not going to be able to. Why? Because you have x squared and then you have x. So you can't factor out x. You can't take x common or anything like that. Okay? So now let me solve this question. So we've done the first step already, x squared minus 6x plus 5. So what do we do in order to bring it in completed square form? We leave a bit of space, then we write plus 5. Now we're going to add 3 squared and we're also going to subtract 3 squared. So what happens here? This becomes x minus 3, the whole thing square. And then 5 minus 9, what's that equal to? That's equal to negative 4. Now you haven't even done step 2 yet. Now you're going to do step 2, and that is you're going to make x the subject. So y plus 4 equals to x minus 3, the whole thing square. Then what happens? We take the square root on both sides. Okay. Now here's a very important concept. When you take the square root on both sides, what happens? If let's say you have x squared equals to 5 and x squared equals to 9, and then you take the square root on both sides, then what happens? Question for you guys. Plus minus. Okay, you get plus minus. But the thing is, remember this. Whenever you're finding out the inverse of a quadratic function, you will either write plus or minus. Okay. Now, how do we determine that? We'll look into that later. Okay. So when you take the square root on both sides, you get plus minus y plus 4 equals to x minus 3 plus minus y plus 4 plus 3 equals to x. Then let's do the final step and write it nicely. That is f inverse of x equals to plus minus y plus 4 plus 3. Okay, and I'll write down a very important note over here. So the note is that we either write plus or minus. We either write plus or minus, but not both. Okay, and the question is, how do we determine whether it's plus or minus? So let's write another note for that. The plus slash minus is decided by looking at the domain. Okay, domain of f of x. More about this later when we're doing when we come across a question where we have to determine. Yeah, the way I wrote isn't correct. Okay, it can't be the final answer. But if that's because we weren't given the domain over here. Okay, so we never leave it as plus minus right now, since conceptually if you take the square root on both sides, you have to write plus minus. But acha, wait a minute, I just realized that it's going to be x plus 4. Yeah, x plus 4, so inside the square root plus 3. So we don't leave it with plus minus. When do we write plus and when do we write minus? We'll get to that. Okay. Shan, if it's not related to this topic, then let's save it for later. Okay. If it is, however, related to the topic, you're very welcome to ask. Okay. All right. So, any questions so far? If yes, please feel free to ask. All right. So here are some questions which I would like you guys to solve. In fact, wait a minute. Just a second. Let me answer this question right now only. Let's not leave this for later. Okay. So I'm going to solve part B, and I want you guys to take a closer look. Okay. So in part B, this is what we have. We have y is equal f of x equal to x square plus 3. Okay. So if I have to find out the inverse, and notice that we're given the domain which is greater than or equal to 0. So we have y is equals to x square plus 3. Okay. Let's make x the subject. So y minus 3 equals to x square. Let's write this nicely. X square equals to y minus 3. Then we take the square root on both sides. So we have x is equals to plus minus square root of y minus 3. And then when we do the final step, this is what we end up with. F inverse of x equals to plus minus x minus 3. Now, like I said, we're not going to leave it with plus and minus. Okay, we will have to choose. Achha, what's wrong with leaving it as plus minus? Let me ask you guys. What's wrong with leaving it as plus minus? Why do you think plus minus is wrong?
So we will get two answers.
Yes, we will get two answers. Yes, we will get two answers. So that's wrong. Okay. Greater or equals than 0. So only positive. ठीक है. Good job. Okay, Nayan, I can see where you're going with this. So basically, remember I said that the plus and minus depends on the domain. Okay. If the domain, I want you guys to pay close attention. If the domain is of f of x is greater than or equal to 0, what will this be of the inverse function? Okay, question for you guys. If the domain of f of x is greater than or equal to 0, what will this be of the inverse function? Yes, good job. It will be the range of the inverse function. Okay, I hope everyone's getting my point here. If the domain of the regular function is greater than or equal to 0, that means that should be the range of the inverse function as well. Okay, now think about it. Should you have a plus sign here or a minus sign here so that this end result remains greater than or equal to 0? What do you think? We should have a plus sign. Okay, so that means when we're giving our final answer, our final answer will be f inverse of x equals to positive square root of x minus 3. Okay, and you will write down the positive sign. Okay, you will show the examiner that you've understood that you have to go with the positive sign. Okay, so I'll repeat what I just said, and then I'll teach you another way. Okay, this method is going to be your backup plan. So if the range of, I'm just repeating now what I said earlier. If the domain of f of x is greater than or equal to 0, that means this should be the range of the inverse function as well. That means f inverse of x should also be greater than or equal to 0, yeah? What we saw earlier. Where exactly was it? Here. Okay, what I've written in red. So now you got to choose. Obviously, only one sign can give you greater than or equal to 0 values. Okay, so now you got to choose whether it's going to be the positive sign or the negative sign. So obviously it's going to be the positive sign. Okay, so that's one way to decide whether it's going to be positive or negative. Now here's plan B. If let's say that doesn't work, then here's plan B. So give me any value that falls in this domain. Any value. Any value that's greater than or equal to 0. 3. Okay. So what's f of 3 equal to? Let's find out. F of 3 means 3 square plus 3. That means f of 3 is equals to 3 square, which is 9. 9 plus 3 is 12. Okay. Now what that means is that f inverse of 12 should be equal to what? If I plug in 3 and I get 12 in the regular function, so now if I plug in 12 in the inverse function, I should get 3. Okay? Now let's see that if I plug in 12 here, so what happens? 12 minus 3 is 9. So what do you think? Should I take the positive square root of 9 or should I take the negative square root of 9 so that I get 3? What do you think? Should I take the positive square root of 9 so that I get 3 or should I take the negative square root of 9? So let's plug it in. Let's find out f inverse of 12. F inverse of 12 means plus minus 12 minus 3. So with which sign do we get 3 as a result? With the positive sign or the negative sign? Which sign gives? Obviously, not both of them are going to give 3. Only one sign will give 3. And that is the positive sign. So that is why we go with the positive value. Okay? So this is your plan B. Okay? Now, any questions? Take a good look at it. Let me know if you have any questions. So it's getting a bit technical, I know. That's what the topic is like. If you thought it's going to be easy, well, then bad news. But yes, with an in-depth understanding, you can make it easy for yourself. Okay, the concepts will remain the same. Obviously, you can't remove a concept, but with an in-depth understanding, you can make the concept easy for yourself. Okay, so yes, this method can be used for any kind of inverse. Any. Okay, so you plug in one value in the normal function, see what you get as your output. Now that same output, when plugged in the inverse function, should give you your input also. Okay, so then you decide whether it's the plus sign or the minus sign that gives you your desired output. And like I said, works with all kinds of function there is. Okay, so I'd like you guys to now quickly solve part A, part C. Part C will be another. Will we need to give a plus before 3, sir? Okay, so this is just for your working. Okay, this is not something that the examiner wants to see. This is the examiner wants to see what sign that you've gone with, whether it's plus or minus. In fact, let me show you guys something. Let me show you. Just a minute. Okay, now. So this is basically a working of an inverse, okay? And this is a working that you guys need to show also. So notice here they have made x the subject, they've taken the square root and written plus or plus minus. And then in the final answer, they've gone with plus. When you don't write anything, it's understood that it's plus. So my point is, you need to show that it's going to be plus minus, and then you need to pick one. Okay, if you don't do this, you lose a mark. So don't think that the plus minus is not relevant here also. In fact, you can see inverse with the plus minus initially, and then they've gone with minus. So why? Because maybe minus, with the minus sign, you get the desired result. Okay, so don't take this lightly. Sir, the C part is completed square form, but isn't it that we can't do an inverse on a non-one-to-one function, which a quadratic equation is? Okay, so glad you asked. Look at the domain of part C. After looking at the domain, you think it's still going to be a many-to-one function? It's a good thing you've pointed out, but take a closer look. Yes, it is because of the domain. It is a one-to-one function. Okay, and in fact, even in part B, if you find out the turning point of this curve, you will notice that it's 0, where x is 0. Even here, you're given x is greater than or equal to 0, which means this makes it a 1-to-1 function. Okay, this is going to be a minimum curve cutting the y-axis at 3. In fact, the turning point will be 0, 3. Because it's greater than or equal to 0, that means we're looking at the part of the curve that is after the turning point. Okay. In fact, you will have questions like these, that explain why the inverse doesn't exist. Questions like these are very common. Explain why f inverse of x does not exist for the given domain. So you will say it's not a 1-to-1, it's a many-to-one function. And then you will have some questions where the question will say, explain why the inverse exists. What's the answer? Because it's a 1-to-1 function. Okay. So I hope that answers your question. So part A and part C.
Sir,
Mm-hmm.
I'm a bit confused that like for the C part, what sign are we gonna use for the in the like
In the inverse?
yes.
Okay. So you're wondering between plus minus. ऐसे है?
जी sir.
अच्छा, अब देखो. Nothing to worry about. All right. First of all, nothing to worry about. If you ever find yourself confused whether you have to go with the plus sign or the minus sign, it's okay. No big deal. So can you tell me what the inverse function is with the plus and minus sign? Plus minus square root.
So square root x minus 3 plus 5.
Perfect. Okay. So now we have to decide whether we're going with plus or minus. ठीक है? So एक काम करते हैं. Let's take any value that falls inside this domain and plug it in the regular function. So give me a value greater than 5. Any value?
7.
7. All right. So let's find out f of 7. So f of 7 means that you're plugging 7 in the normal function, okay, in the regular function, f of x, that is. So 7 minus 5 is 2. 2 plus 2 squared is 4. 4 plus 3 is 7. Okay, that's a coincidence. F of 7 gives you 7. Let me double check. 7 minus 5 is 2. Square of which is 4. 4 plus 3 is 7. Okay, nothing to worry about. That means now, if you plug in 7 in the inverse function, you should also get what? What should your output be? It should also be 7. Okay, now let's see whether we get 7 with the positive sign or we get 7 with the negative sign. Okay, so f inverse of 7. That means 7 minus 3 plus minus plus 5. Okay, so what's 7 minus 3? 7 minus 3 is 4 plus 5. Now, can you answer your own question whether we're going to go with the positive sign or the negative sign?
Okay, sir. So like we will use the positive.
We'll use the positive sign. Why? Because it's the positive sign that gets us back to 7. Okay, so our final answer of the inverse is going to be positive square root of x minus 3 plus 5. Okay, now let me tell you something. There is a standard rule for this also. Okay, there is a standard rule for this also, which I will give you guys, but not right now. Okay, there is a standard rule that when it's greater, it's this, when it's lesser, it's that. Okay, but it's different for a minimum and a maximum curve. But I'm not going to give you guys that just yet because I want you guys to be open to the idea of doing a bit of trial and error, because you will have to do trial and error, especially when you're finding out range of a function that's neither a 1-to-1 function nor a quadratic many-to-one function. Okay, it's a completely different, maybe like an irrational function or something like that. That is when you will have to do a bit of trial and error. So I want to keep you guys open to that. That's why I'm not going to give you the standard rule just yet. I will, but not just yet. Okay. Okay, so can I have the answer to part A? It's a fairly easy question. Then I'll solve part D. X plus 8 upon 5, is that correct? F inverse of x equals to x plus 8 upon 5. Yeah, okay. Good job. Now let's do part D. In part D, we have f of x equals to 8 over x minus 3. Okay, and you're given x is not equal to 3. Understandably so. Why? Because if it's equal to 3, what happens? The whole thing becomes undefined. Okay. Acha, so what do we do now? Here's what we do now. So y is equals to 8 over x minus 3. You cross multiply. Xy minus 3y equals to 8. Remember, your objective is to make x the subject. So all the terms that have x in them, you got to keep them on one side and shift everything else over to the other side. So now if you make x the subject, x is equals to 8 plus 3y upon y. Okay, and then you can do the final step, which is f inverse of x equals to 8 plus 3x upon x. That's it. That's your answer. Okay, Nayan, you asked me that question. All good now? Okay, so I'm going to keep it till here only. All right, we've done the main concept of inverse. Repeat what, Fayaz? Repeat what? This? Okay. So in the last part, I said, remember, your objective is to make x the subject. So you keep all the terms with x on one side and every other term on the other side. So this is x equals to 8 plus 3y upon y. Then what's the final step of finding the inverse of a function? You replace x with f inverse of x and y with x. So that's what I've done. Replace y with x. Yes, of course. Wasi, you can always do that. You can write this as 8 upon x plus 3x upon x, in which case the x and x cancel. And now you have 8 upon x plus 3. You can always do that. Okay. Now the question is, do you have to? No. But if the question says so, that you have to write it a certain way, then of course you have no choice. Okay. So like I said, I'm going to stop here. I'll see you guys inshallah on Tuesday. Let's try and finish functions in December only. I think we're going to get 3 more classes before the end of the month. So let's try and finish this month strong, inshallah, so we can start differentiation as soon as January starts. Okay? So I'll stop here. See you guys on Tuesday, inshallah. Take care, everyone. Yes, Ali, I will be giving you guys homework today. Okay? I will be giving you guys homework. So take care. Love this.